My name is Doc Brown. I am a local crackpot inventor.
And hi, my name is Marty McFly, and I'm a slacker. No, just kidding. We are engineers at Jamf. We're not characters from a movie. My name is Matthew Phillips. I'm a senior consulting engineer.
And I am Daniel McLaughlin. I'm also a senior consulting engineer. So if you haven't already guessed, there will be quite a few references to the Back to the Future movies. So apologies to anyone who hasn't seen them. Knowledge of the movies will not be required to benefit from the content of this presentation, but some jokes might go over your head.
Okay, so the agenda. First up, flux capacitor. This is what makes time travel possible. Specs and requirements, we're going to need to travel 88 miles an hour, and we're going to have to power the flux capacitor with 1.21 gigawatts. Later, we're going to get into some heavy stuff with Doc. And Johnny Be Good. This is the section of the presentation where you call up your cousin Barry and convince him about that new sound that he's been looking for. And most importantly, your density. The moral of this story is your destiny isn't written yet. Choices you make now can affect the future.
Thanks, Matt. So in non-Back to the Future terms, the goal is to make a certificate, and with that certificate, use it within your organization. Cover some key components needed to achieve this goal. We'll go a bit deeper into some certificate terms and scenarios, addressing some of the factors that affect the end users and how you as an admin can manage certificates.
So Doc Brown invented the flux capacitor after being hit on the head, and sometimes dealing with certificates might feel exactly like that. In this analogy, the flux capacitor is the leaf cert, sometimes called the blue one. That's not exactly accurate, a bit of an oversimplification, but it does distinguish them from root certificates, which on a Mac are represented with a gold icon. Certificates are used everywhere in modern computing and device management. They are used to leverage secure communication with web servers. Certificates can be used to encrypt emails. Also, certs can be used in place of credentials to connect to things like VPN and secure Wi-Fi. You know the quote, roads, where we're going, we don't need roads. Well, have you been asked in your organization to go passwordless? Well, certificates are how to do it. In this session, where you're going, you don't need passwords.
So now let's talk about some specs and requirements. In order to time travel, we need a few things. We need power, a source for that power, nice long stretch of road or track, and a stylish mode of transport. In cert terms, what we need to deploy certificates within our environment is a certificate authority that will be issuing these certificates, a template that will define the usage and guidelines of the certificate that is issued, a certificate signing request, also known as a CSR, and a subcomponent of that CSR, which is what is called a private key. We'll go through these in greater detail later. Marty! Marty! There's a problem with your certs, Marty!
Doc, what, Doc? Something happened to my root CA? Does my intermediate get compromised? What?
No. You and your intermediate are fine, Marty. The problem is with your leaf certs. Something's got to be done with your leafs.
What does that even mean?
So when we talk about root and intermediate and leaf certificates, we are referring to the certificate chain. Here we can see a certificate for Jamf.com. The gold certificate at the top is the root certificate, which has issued an intermediate certificate, and then the intermediate certificate, which is also a certificate authority, has then issued the leaf certificate, in this case star.jamf.com, which is also known as a wildcard certificate. We can also see by the green tick that this certificate is valid and trusted as the full chain is present and the certificates haven't expired. Not to be confused with certificate trust, there is also something called certificate compliance. These standards are for internally issued certificates and have different validity lengths compared to our publicly issued ones. Let's look at the differences. Here we have an internally issued certificate that is not trusted. It is not trusted because the issuing certificate authority isn't trusted or present on the device, and as such, the cert chain is missing. On the right, we have a non-compliant certificate. You will see the red text is differently worded because reading is hard. You will see this message even if you have the full trusted chain present. The reason that this certificate is not compliant is that the expiration date is in 2029, which is longer than the maximum of 825 days allowed. Apple's knowledge base article about this, which you saw in the previous slides, states this, and the link will be available in the resources section at the end of this presentation.
So, looking at a different Apple K-base article here about the upcoming limits on trusted certificates. Unlike certificate compliance, which pertains specifically to internally issued certs, this recent change affects the validity period of publicly trusted or root certs. Back in the day, if you wanted to minimize how often you needed to update your server certificates and appear to be more trustworthy, you could plop in a cert that was good for, say, 5 years. Certs are easy enough to buy from a third-party CA. Usually you get a price break from places like Komodo or DigiCert if you buy 10 years worth. But as of September 1st, 2020, certificates are no longer valid longer than 398 days. What does that mean for you? Well, not much, but there is an important distinction about downloading the certs. You can still pay ahead of time for 5 or 10 certs, 5 or 10 year certificates, but just know that you will have to download a new cert every year and replace the old one that's installed. This change is an effort to ensure that stale sources of truth don't accidentally become bad actors over time.
As mentioned previously, we need some components in order to request and issue certificates. We need a certificate authority. For internal certs, that is an internal server, such as a Microsoft server running the certificate authority service. This would be considered a private CA, used within your organization only. This is used to issue, validate, revoke any certificates that are administered, and is a core requirement of using certificates within your organization. We need a certificate template. By default, there will be a number of templates available to the CA server, and the template defines what usages the certificate will have and how long it will be valid for. Once we have our CA and appropriate template ready, we submit to the CA a certificate signing request. This CSR is comprised of the information about the certificate that is to be generated, such as the subject name and any additional alternative names. And in order to build a CSR, we need to reference a private key. The private key will be used to validate the certificate that comes back from the CA. If compromised, can affect the issued certificate. It is important to keep the private key private.
Yeah. So identity. Why all of a sudden does this matter? Calvin. It's your name, isn't it? Calvin Klein. I see it's written on your underwear. So identity is important because a case of mistaken identity can really change the course of history. Remember when we talked about going passwordless earlier, this is how we do it, by putting the username or machine name or any other identity data inside the certificate. So when your device presents that cert when prompted, if it has the wrong content, the server might think you're wearing someone else's underwear. When talking about identity certs, 2 important details matter when deploying them to your devices: content and context. Very similar words with very different meanings. We're going to take a look at what defines a device level, machine cert, user level, and user cert. Which one you use and how you use it depends entirely on your environment and what the service is expecting. So here we have basically 4 possibilities. We have 2 details, each with 2 possibilities. So we're looking at a device level certificate, which means it's installed in the system keychain. And the content of that certificate, you'll see here in yellow, is $computer name, which makes it a machine cert. There is no user identity contained inside. This is a common cert deployment for getting data into device data into system keychain, so it can be used at any time by any user of the device. Next up is a user level machine cert. So instead of the system keychain, Jamf is going to be installing this certificate into the user's keychain. And the content of the cert is still $computer name. So this specific example is pretty fringe case. We wanted to demonstrate that these options are possible, and you might need this in your environment, but it's much less common. Last up, the two styles we have are a device level certificate, where the certificate is being installed in the system keychain, but the content of the cert at this point has changed to CN $full name, which in this case is Marty McFly. So we have a device level certificate available to all users of the device that's being that has the user's information installed in it. This is super common for any 802.1x Wi-Fi model where the system would need access to this certificate at the login window. And last, we have user level user certificate. At this point, it's pretty self-evident. The certificate is going into the user's login keychain, and the content in this case is still Marty McFly. This could also be used for 802.1x Wi-Fi, but would not be available at the login window. So you can still use it for things like VPN or intranet. And depending on your own environment, any combination of these scenarios might be appropriate. But let's talk about this extra bit down here in the red box for SAN. This is the subject alternative name. And notice here we have $email and UPN in the SAN fields. Those show up on a deployed certificate here in Keychain. Dan, you want to take it?
Sure. So we can see here, if we expand out the full certificate that's installed, we can see that these subject alternative names, or SANs, refer to. Some usages may require both a user's full name and then the UPN in the same certificate. Rather than deploying two separate certificates, we can combine them into one. And the possibilities are endless here. You could, of course, deploy a machine certificate with the subject of, say, $serial number, but it also includes user data in the SAN for something like $email address.
Man, Doc, this is all real heavy stuff.
There's that word again, heavy. Why are things so heavy in the future?
So, into the heavy stuff, what you're looking at here on the screen is a text file. This is a certificate. It's as simple as that. Certificates are text files. The details that matter come down to the file type, the encoding format, and the file extension. We're going to go over some of those tools used to identify certificate types and how to manage them. When dealing with certificate files, it's all quite a bit overwhelming, but if we arm you with at least a high-level knowledge of what it is that you're looking at, then you at least stand a chance. Questions like, what are the file extensions and why does it matter? Sometimes it's as simple as changing a file extension from .cer to .crt, but you'll find that that trick doesn't work for something like a P12 certificate bundle. And passwords. Why are some certificates password protected? You'll find that encoded certificates that include a private key are password protected.
So we have two types of encoding for certificates. The first is what is known as base64. It's referred to as a plain text format, and while the screenshot doesn't seem very easy to read, it does conform to some structure. You'll notice the header and footers are human readable and are required for this type of encoding. This format is most commonly used by most systems, and if you were to export a certificate from a macOS keychain, then drag that certificate to TextEdit, you'll see a similar output. Trust me when I say this, base64 is easier to read. As here, we have the exact same certificate as the previous image. However, this one has been encoded in as binary instead of base64. You can see there might be some words scattered throughout, but I wouldn't call this one human readable. It is a preferred format for Java-based platforms. We have here a handy map to identify the different encoding types and file formats for various certs you will find in the wild.
Yeah. So we'll give you a moment to look at this chart. It breaks down the various file extensions and formatting type. It will be available later in the resources as a download, so you don't have to screenshot it or steal it just yet, but it can be used as a handy certificate cheat sheet to understand which file type you're working with when you're looking at a cert. Okay, so the certificate tools we can use. Let's talk about the general problem that needs solving. Usually that would be acquiring the certificate that is being presented by the server. This may be an AD cert or the SSL cert for a website. First step, we're going to go into Terminal and we're going to use a command line tool. We're going to move over into text edit, and we're going to write a text file. After we save the text file, we can look at it with quick look in Finder, and then optionally, if you wanted to, you could install that certificate into Keychain. So here in Terminal, we're going to be using the OpenSSL command, which is natively installed on macOS. We're using a subcommand where OpenSSL is acting as a client, reaching out to the server specified. That's after the -connect here at jamf.com:port 443. The resulting command reveals that the certificate that's being presented when you navigate to that URL. This is an extremely useful step in troubleshooting expected behavior with web servers and different services. So next, grab the text, including the certificate headers. You'll want to grab the whole thing, including the dashes, copy it to your clipboard, and launch your favorite text editor. In this case, we're using built-in text edit. One important note on text edit is that you'll want to change the file format to plain text. Then when you hit save, change the file type from .txt to .cer and save. Now you have yourself a cert. Once you're in Finder, you can hit spacebar and take a quick look at the contents of that certificate that you just pulled down from the web server. At this point, you could install it into Keychain, but that's rarely something you're actually going to do meaningfully when you're troubleshooting and testing. Now, getting back to the future, we have come to the song and dance portion of this presentation.
And by that, we mean it's like we're coming to the part that makes users' lives easier, and by association, the admins. What we're going to show you are 3 different scenarios that we've encountered that influence how we plan the usage of certificates in different environments. We first find ourselves in the year 1955. Things are simpler, and as such, a bit more manual. This scenario, we're going to start with uses the protocol known as PEEP, and the user is involved in every step of the connection for connecting to an 802.1x Wi-Fi network. Here we have our machine. We go up and we click on the network. We see 1955. We are then asked for our username and password, and like most users, we don't know how to type our name. We are then prompted, after we type in the right name and password, to trust a certificate. This is not certificate-based Wi-Fi. The certificate is the Radius certificate, and it is presented by the authentication server. We are then prompted for local credentials to install and trust the certificate into the keychain. Once this is completed, we are connected to 1955. You'll notice at the bottom of the network window that this is a PEEP method. So we've learned some things since 1955. So we traveled to a time where we have the infrastructure to deploy a certificate for our Wi-Fi network. But someone must have stolen a sports almanac, as this isn't the experience we expect. We're using MDM to deploy a user certificate, but the user is still prompted and has to do some manual steps. So here we can see we are going to select 1985 as the network. In the drop-down, we will see that there is a certificate available to us. But I'm still prompted to ask for a certificate, and now I have to type in a local account in order to add it to the keychain. But then it needs another prompt, and this prompt is to associate that certificate with the Wi-Fi. Finally, after jumping through all these hoops, we're online, but this is in the future. So after going back and correcting the timeline, Biff is back to washing cars, and we can now see a bright future ahead of us with our certificates being deployed and automatically trusted. The user is unencumbered by confusing prompts, and we're just waiting on our hoverboards to arrive. So if we have a look here, we can see that we are still in 1985. But if we open our Jamf Pro console, we have a configuration profile that has all of our necessary certificates. The full chain with the root cert, the radius cert. All right, gone ahead. There's the root cert. And then if we scroll down, there's our radius certificate, NPS. And then finally, our user certificate. We will then go over to our network payload in the same profile, and we'll have our SSID 2015. We will scroll down and we will select the authentication type as TLS, and the identity certificate is our user certificate. We then also go over to our trust, and we make sure that the radius certificate is also trusted. We'll then finally go up to our scope, target our device, and hit save. From the user's point of view, we can see that we will be shot straight through to 2015 automatically without any input from the users. I will also like to note that none of these videos that you saw were sped up in any way, and the macOS version that we were running at the time of recording was the latest available to us, which was 12.4.
And with that is the end. Or is it? Obviously, your choices change your future, and we've just proven that not only is time travel possible, but your choices will change your future as a Jamf admin.
And so with that, we'd like you all to know that the ultimate usage of certificates is in your own hands. We hope that you've taken some knowledge from this presentation. And as promised, all the links and as well as some other resources will be available on the slides here. The QR code and the links are all related to the same location. We just wanted to be visible in that. And with that, thank you very much from a crackpot inventor, Marty.
And everyone's favorite slacker. Thanks, all.